Alright, so let's see if I can make this from scratch. In the last video I talked about chemistry and matrices, and so I'm not going to go into exactly what I was talking about. I'm going to go into something that's similar, but it's still chemistry. And so if you're in chemistry class, pay attention. This is actually a way that I came up with that makes adding the weights of elements easier. And I'm going to butcher the program because I don't have it in front of me, and I wrote it a while ago, and it requires a lot of inputting the values of the periodic table into a matrix, but it'll help you. So the idea was, if I can input let's see, number is equal to, and then you have, we'll go n, and then so that's the number, the element number you're talking about. So if you have element 1, element 2, whatever number you have, and we're going to say n, and then we'll store it as, yeah, we can store it as a list. So we're going to do n store eat list 1, element 1 plus dimension of list 1, and you also have to have a matrix. And so the matrix is matrices. So you can make a matrix by actually going to second and then the x inverse that I talked about in the last video, and so that actually will open up the matrix screen. Ooh, there we go. And then you can go into edit, which is 2 over, and you can edit matrices there. And so for the matrix that you want to make, it's needs to have, I don't think I can do this. Does it need to have both? No, it just needs to have one. So you're gonna have like your matrix A, which is like this, and then below that you need to have all of the is it numbers? Do you really need numbers? No, you don't need numbers. So you can just input all of the weights, and so I don't know exactly what the weight of hydrogen is, but I think it's 1.008. It's been a year. And then you can put in the next value, which I have no clue what it is. But you go through and you just list all the weights. And there's actually a periodic table on your calculator, so if your teacher's like, here, memorize the periodic table. Oh, it's also going to be on a test that you have math on. You also have that as an app, and I might do a video on that later. But to the matter at hand. So you have your list, your matrix, I usually did like J, matrix J, which has all your weights. And so what you need to do to be able to access that in the way that I can think of that is easy right now is to store matrix J to list like 2. And like I said, I'm going to butcher this, but you can, I think there's a matrix to, actually there's a function for this, so that's not exactly how you're supposed to write it. To list, I think it might just be LST. Oh, that's probably LIST. And then you need to give it the matrix, so it needs to be matrix J, and then the list, and so it needs to be list 1. And or list 2, I guess, which would be better. And then so now you have your list that has all of the weights of the elements. And so then below that, you need to actually put this line, and it needs to be L, oh, no, that's not what I want to do. And this, because it needs to be L of n, and so you need, this is the number, and the matrix, or the list that you have, has the elements listed in, I wish I had a way I could draw this out, I need to work on that. But you have your list, and then you have all your values, and if you say list at element 5, so if you do list of 5, again, not how you're supposed to, this should be like this. There you go. At 5, or at 6, whatever, then that's going to evaluate to whatever the number is at 5. And so if you have this list 1, which is all of the weights of the elements, then at the element number 5, because it's in the space number 5, will give you the weight of element number 5, because that's how you've set it up. And so when you call on or list 1 element n, because that's the number of the element you're looking at, then it'll give you whatever that is. And so you want to store it not at list 1, store it at list 2, because then we can take the sum of list 2. and then we want to store it at 1 plus the dimension of list 1, or list 2. Sweet. And then this actually just needs to be loop. So label A, and I kind of did this in the last video a little bit. And then you should say if n equals 0, and so then we need to do display, it needs to be above because it's really annoying when you have to see it a bajillion times. So display, what was it? N equals 0 equals done. And there's a better way to write that, but on the fly. I'm literally doing this on the fly. So then you want to do end. No, actually, you don't need to end because it's just one line. And so then, when you're done, this needs to be a not equal to. And then when you're done, anyway, when you're done, you're going to take sum of list 2, and you're going to display it. So you can actually just write display disp, not diosp. So display sum of list 2. And so you need to add this as a not equal to, which in actual programming, well, I say actual programming, but in other programming languages, what you can do is make that an exclamation point and do exclamation point equal sign, and that'll mean not equal to, because that kind of looks like a straight line, and exclamation point's a straight line. So if n is not equal to 0, then store the list 1 element n at list 2, 1 plus dimension of list 2. And so you should get, after you run this like 5-6 times, you should have a number of elements. Now the downside is that you have to input how many elements you have. So you can't just put, I have 5 of element 3. Like you have to write in, you have to put in 3 5 times. So it's kind of, there's a better way to write this, but you should have seen the way. I should be able to, I think I have it on a USB stick or flash drive. I have the original equation, or the original program for this, and that thing was, oof, that thing's ugly. So if you do this, this should, as long as you have matrix J as the list of weights, then this should work. Now I must warn you against 2 things. One, don't just store the list of values at list 1, because eventually you might accidentally clear list 1, and then all your hard work's gone. And so then, as long as you don't delete matrix J, which is why I have it at matrix J, because it's really, like, you have to, it's kind of out of your way to go and delete matrix J. It's easier to delete other matrices because they're on the top of the screen, and then matrix J and I think H are down below the screen. The other thing you could do, and I would warn you against this because I'm not so sure how it would work, if it would work, but you should be able to, instead of having to call on a list, so instead of having to do this entire step at all, you should be able to read it from the matrix by itself. And so you should be able to take this as matrix J, because it should be a straight line, because there shouldn't be 2 dimensions, it should just be element after element after element. Like, so it would be a straight line, no, like this. Can't do a very good example of it. There we go. And so they would look like that instead of your other matrices, which would be and so you'd have multiple dimensions, and so you'd have to then specify which specific one you're looking at. And if you did it that way and you were more precise about it, and it would take more lines, but you'd be able to fit in more elements, because lists or matrices I think can only hold 99, and so there's like 118 elements, or some, there might be more than that now, but there's over 99. So if you have any elements that you're talking about that are over number 99, then you might have to, if you really need to, you can then edit this program to accommodate for that. Actually, you should be able to have counter, and so it would just read it. Might take a little longer, but it would read it like this, and so you'd have. Might do that next. you'd read it like you have this is element 1, this is element 2, element 3, element 4, element 5, element 6, element 7, element 8, element 9, so on and so forth, all the way down, because that way because you can have a list that is or a matrix that is 99 by 99, but you can't have a matrix that is 100 by 1. And so instead of having like a list, and then the downside of that would be that you can't store this as a list, but you could store it as sets of lists. So you could have this be like this half be list 1 and this half be list 2, but I might see if I can do that next. Anyway, that's how you would make a program that would add up the weights of a specific compound or a number of elements. Hope you guys found that helpful, and see you next time.